You are given exactly 60 seconds to answer this question. If you're done with your answers, you can skip the timer and proceed to the discussion portion to verify whether your answers are correct or not. If you may, you can share your answers as a comment in the comment section below. If you need more time, you can pause this video in any moment you want. Your 60 seconds starts now. Aside from the special arcs on a unit circle, let's say pi over 6, pi over 4, and pi over 3, to which one of the items is here, there are also other multiples of such. And before we could determine the coordinates of the terminal points of such arcs, we need to understand the location of their terminal point. Let us consider this unit circle here to illustrate that as we talk about them one by one. But here's the catch, and you need to remember this from time to time. All of our arcs here are positive. And here comes the movement of each arc. When the arcs given are positive, we are going to move counterclockwise, starting from the zero portion or the origin point, the initial point. And as soon as you will have your portions of your arcs, you move it counterclockwise. That is if your arcs are expressed in positive forms. Okay? Take note of that. Just like the movement of our quadrants. From quadrant 1, quadrant 2, 3, and 4, it moves in a counterclockwise motion. That's also the motion of our arcs. So we are going to illustrate the idea of the unit circle and their locations by the idea of multiples. Now before that, it's very important to understand that this entire unit circle here, the arc in degree measurement, is actually 360 degrees. We know that to be 360 degrees. Okay? It's the degree measurement of an entire revolution. Now let's look into the conversion of this into pi radians. Okay, pi radians or radian measurement, because all of our arcs here are in terms of radians. We can convert 360 or any degrees into pi radians by this given conversion factor, pi over 180 degrees, because we know that pi is just 180 degrees and this is equal to 1. So we expect that our result will have pi here, okay? And we divide 360 degrees, we cancel degrees and degrees, by 180, you have 2. That's what mean 360 degrees is or one revolution for our unit circle is just equal to 2 pi. This would mean, but if we are going to revolve or move the arc from here, going there, until here, sorry, my revolution is not that accurate. Just like that, we are doing 2 pi movement in terms of radian measures. And why is that very important? Because in determining the location, we need to understand that the entire circle here is pi at 2 pi, and if we are going to just end up until here, so from here to that, it's just a semicircle, right? So from here to that is just semicircle. So semicircle is half of the circle. So half 2 pi, that would mean this is our pi here. Okay, that's one thing you need to remind ourselves. This is pi. Of course, if we're going to divide further, this is pi over 2, but let's try to look into it later. Okay, and we might have answers already to this last. Okay. So let's just look into that the semicircle is just pi in itself. So earlier, or the previous video, we're able to locate pi thirds already, because pi thirds is just equal to, in degree measurement, equal to 60 degrees. You can verify that using a conversion factor as well. But let's not put degrees here to emphasize the idea of this pi. Pi over 3 means the pi, the semicircle, is divided into 3. That's its point. The pi is divided into 3. If we are going to divide this into 3, probably something here. We have 3 slices of pizza. Okay, so this is our first pi over 3, our second pi over 3, and our 3 pi over 3 is just equal to pi. This is our pi over 3 because it's just 1 pi over 3. Okay, so for pi over 3, we can locate this on our first quadrant. Okay, so pi over 3 is on the first quadrant. And by the way, why is it that it's very important to locate the correct location in terms of quadrant of our arcs? Because, of course, our point here is a combination of x and y. And each quadrant has specific behaviors as to the x and y values. So if ever you're looking for a multiple of pi over 3 soon, you first locate the quadrant so that you would know what would be the sign of your x or y. That's for pi over 3. Okay, so let's move to pi over 6. Okay, pi over 6. So pi over 6 is when you divide pi into 6 parts. So we have this pi here. This is the pi. That's our pi. Because 6 is a multiple of 3, so we can have it like that, and here. So this is our pi over 6. Okay? This is our second pi over 6, or pi over 3, because our 2 pi over 6 in terms of lowest terms, I will have 2 pi over 6 in terms of lowest term is actually pi over 3, right? Okay. This is our 3 pi over 6, our 4 pi over 6, our 5th pi over 6 is somewhere here. This is our 5th pi over 6. We divided our pi into 6 parts and we're taking 5 portions of it. So 1, 2, 3, 4, 5. In short, our 5 pi over 6 is located on the second quadrant. And it would follow that the coordinates of this will follow the sign of x and y in the second quadrant. Now let's look into pi over 4. Since this is already a little bit crowded, let's try to use another. Okay, use one here. Let's use this another unit circle. As mentioned, we know that the semicircle is just half of the circle. That's pi, because our entire circle is 2 pi. So pi over 4, that's the denominator. 7 pi over 4. So let's first divide our pi into 4 parts. This one here, and this one here. Okay, so assuming that my division is correct, this is our first pi over 4, the second pi over 4, the third pi over 4, and the 4 pi over 4, which of course 4 pi over 4 is just equal to pi. But our question here is the terminal point of 7 pi over 4. This would mean we will continue. This is also another pi, right? This is also another pi. So if we're going to divide it by 4 as well, okay, we have like that. So let's proceed. This is our first pi over 4, second pi over 4, third pi over 4, 4 pi over 4, the 5th pi over 4, 6th pi over 4, and our 7th pi over 4 is here. Therefore, our 7 pi over 4 is located at the 4th quadrant. Okay, and it will behave, the points will behave as the signs of the points on the 4th quadrant. Let's proceed to our next 3 pi over 4, 3 pi halves. Let's just simply use this one here. So pi halves. Our pi will be divided into 2. So no, don't remove this, remove that. Our pi will be divided into 2. That's our first. So we have pi halves. Second pi halves, or simplify pi. Our third pi halves is here. This is also pi halves. Okay, this is our 3 pi over 2. However, 3 pi halves is not located at any quadrant. It's actually on the an axis. So to answer the question, 3 pi halves is not on any quadrant, of course, but it's on our y-axis. Okay, it's on our y-axis. This might not be the answer because the question is talking about quadrant, but nevertheless, we're going to label it y-axis because 3 pi halves, or 3 pi over 2, as the first pi halves, second pi halves, and 3 pi halves is found in the y-axis. And with that, since it's found on an axis, its coordinate would be integer because this is an integer here. Okay? How about 2 pi? As we know, 2 pi is the entire revolution. So where could we locate 2 pi? If we started here, that's 0. 0 pi, or just simply our initial point. So we roam around, or we revolve, and we reach to a 1 revolution, which is 360 degrees, equivalent to 2 pi. In short, the location of 0 and 2 pi is just the same. And still, it's not on any quadrant, but it's on an axis, more specifically x-axis. Same as 3 pi halves, it has integral values of x and y. So as a summary, pi thirds is on the first quadrant, 5 pi over 6 is in the second quadrant, 7 pi over 4 is on the fourth quadrant, 3 pi halves is not on any quadrant, nor 2 pi, but they are both on axes, namely y-axis and x-axis respectively. This is very important as we move further into determining the coordinates of these given arcs. Thank you for watching.